You draft a razor-sharp wing across your eyelid. It looks perfect, but the moment you open your eye, the skin folds, and that pristine line instantly collapses into a jagged smudge. A dull, bleeding, or wobbly wing is a diagnosable mechanical failure. This failure begins with the chemical composition of your formula. Every eyeliner behaves strictly according to its ingredients. The second variable is the calibration and stiffness of your application tool, which must compensate for the physical limitations of those ingredients. The final variable is geometric. A perfect line will still fail if it is plotted against the wrong anatomical topography. By treating the eyelid as a mechanical canvas, we can troubleshoot these specific failure points using cosmetic chemistry and geometric mapping. Mastering these three variables makes eyeliner application an engineered, guaranteed outcome. All eyeliner mediums exist on a specific chemical spectrum, ranging from high blendability to structural rigidity. Pencil and gel liners occupy the blendable side of the spectrum. They are manufactured with heavy concentrations of waxes and emollients, allowing the pigment to glide smoothly over the delicate skin of the eye. This inherent softness makes it physically difficult for the formula to maintain a razor-sharp edge without crumbling under pressure. You can alter this wax structure through temperature manipulation, specifically the freezer hack. Placing a soft pencil in the freezer for 10 minutes hardens the waxes. This temporary rigidity allows the blade of a sharpener to carve a crisp, precise tip without catching and tearing the emollient formula. Liquid and felt tip liners occupy the opposite end of the spectrum. Instead of waxes, they rely on water or alcohol bases mixed with synthetic polymer film formers. As the liquid base evaporates, these film formers dry down instantly. This creates a high-fidelity structural edge that holds its shape entirely on its own, offering zero forgiveness for application errors. This chemical spectrum dictates the physical relationship between the formula and the tool used to apply it. A potted gel liner is highly emollient and requires an angled, flat synthetic brush. The stiff edge of the brush enforces the rigid architecture that the soft gel lacks on its own. The tool and the formula exist in a balanced ecosystem. A soft, forgiving formula requires either a hard tool or temperature manipulation to achieve precision. The eyelid is a highly mobile anatomical feature that constantly generates heat, friction, and natural sebum. Waxy pencils or emollient gels interact with an unprepped, oily eyelid through a specific chemical reaction. Your natural eyelid oils act as a solvent. Over a few hours, those oils physically break down the pigment base, causing the sharp edge to migrate and bleed into the surrounding skin. This cross-section demonstrates the mechanical solution, creating a physical, dry barrier between the skin and the eyeliner. Applying matte primer builds a boundary layer. This layer repels oils attempting to push upward from the skin, while providing a micro-textured surface above. This textured surface gives the film formers and waxes in the eyeliner something to physically grip, locking the pigment securely in place. A sharp edge cannot survive on a solvent. Formula longevity is entirely dependent on the structural integrity of the base primer underneath it. Drafting a two-dimensional line on a closed, stretched eyelid creates a specific geometric error. When the eye opens, the three-dimensional reality of the face takes over. The skin compresses and folds, distorting that flat 2D draft into a jagged, warped shape. This distortion is severe for deep-set eyes, where a prominent brow bone creates a natural vertical shadow over the lid. Dragging eyeliner to the inner corner visually closes off a deep-set eye. To prevent this, the line must originate from the middle of the iris and taper outward. Hooded eyes and monolids face a different constraint. A fold of skin drops down, completely hiding the available lid space. The wing must be deliberately drafted outward past the fold, or uniquely contoured to compensate for the overlapping skin. All eye shapes share an outer boundary restriction called the orbital bone limit. This is the narrow spatial gap between the outer corner of the eye and the curve of the temple. Hitting this orbital limit forces a long wing to physically curve downward, counteracting the intended lifted effect. To maintain an upward trajectory, the line must be truncated into a shorter kitten wing. Successful application requires calculating the trajectory of unique anatomical folding points. The stamp and connect phase serves as the geometric drafting process for the final application. Mapping the shape first with powder eyeshadow allows for angle corrections before committing to rigid, waterproof film formers. The starting posture for this protocol is looking straight ahead into a mirror with all facial muscles completely relaxed. This reveals exactly where your true resting folds sit. This wireframe diagram illustrates the first step, locating the correct angle by following the lower lash line. Following that projected path, stamp an angled brush at the outer corner to create a guide mark without dragging it. Next, place a small dot on the upper lash line directly above the outer edge of your iris. Connecting the outer stamp mark back to that inner dot forms a lifted triangle that bypasses folds or shadows. With the geometry confirmed on an open eye, you can trace over this shadow map with liquid or gel eyeliner to lock in an absolutely sharp edge. Decoupling the drafting phase from the locking phase eliminates the risk of anatomical distortion ruining the final look. Achieving a razor-sharp wing relies directly on your ability to control 3 intersecting mechanical variables. Control the formula chemistry by freezing soft waxes or selecting liquid film formers for absolute structural rigidity. Establish a sebum-free primer barrier to prevent natural oils from inducing pigment migration. Draft your geometric boundaries on an open, relaxed eye to safely navigate around unique anatomical folds and orbital limits. Success requires a universal mapping protocol adapted to your specific facial topography. Understanding these mechanics removes the anxiety and guesswork traditionally associated with eyeliner application. Precision is an engineered, highly repeatable process. When you diagnose the mechanics of the canvas, you stop fighting the anatomy of your eye and dictate the final result.